Right, hello there, and a very warm welcome to this explainer. Today, we're going to completely dismantle a time-honored, yet, let's be honest, thoroughly flawed academic tradition. I'm talking about the dreaded 3 a.m. cramming session. If you've ever found yourself surrounded by a mountain of empty coffee cups, frantically highlighting textbook pages the night before a major exam, well, you're absolutely in the right place. We're going to look closely at the neuroscience of learning to uncover exactly why our brains just rebel against last-minute studying, and, more importantly, what we can do instead to achieve brilliant results without the absolute exhaustion.
So it's a question we really have to ask ourselves, isn't it? Why does last-minute revision always seem to fail us the second we sit down in the exam hall? Now let's validate that panic-driven tradition of cramming for just a second. We do it because, well, it feels incredibly productive in the short term. It gives us this comforting illusion that we're absorbing absolute mountains of information in record time. But the harsh truth? Cramming relies almost entirely on our severely limited working memory. It's essentially a temporary storage system that holds information just long enough for you to scribble it down on a test paper, only for it to completely evaporate soon after.
Okay, let's dive into this. 70%. Yep, you heard that right. That is the staggering amount of new information we literally lose within just 24 hours unless we actively review it. To put that into perspective, it's like pouring a bucket of water into a colander. This harsh reality is known as the forgetting curve, a phenomenon famously discovered by the psychologist Hermann Ebbinghaus. Essentially, when we cram, we are running a desperate race against this curve, and without implementing the proper strategies, we are absolutely destined to lose. The information simply doesn't stick around.
To understand why this happens, we really need to look at the hidden biology of learning, specifically cognitive load theory. You see, our working memory is actually incredibly fragile. It can actively process only about 4 to 7 new pieces of information at any given time. So when you try to force, say, 10 chapters of a dense history textbook into your brain in a single night, you completely exceed this biological limit. Your attention falters, the learning stalls, and you trigger a state of cognitive overload. This overload acts like a massive roadblock, completely preventing the transfer of knowledge from your temporary working memory straight into your stable, long-term memory.
This foundational theory of cognitive load was actually introduced by John Sweller back in 1988. Sweller's research proved that the design and the pacing of our learning matters just as much as the content itself. We absolutely must work with our brain's architecture, not against it. Look, relying on 6 cups of absurdly strong coffee and sheer midnight panic might miraculously keep your eyes open, but it certainly doesn't expand your working memory's natural capacity. You're quite simply pouring water into a glass that's already overflowing. It's just a mess.
And, as if cognitive overload wasn't quite enough of a headache, cramming introduces another sinister saboteur: stress. It traps us in what's known as a biological cortisol trap. When you're panicked about an impending exam, your body's stress response triggers the HPA axis, flooding your bloodstream with the stress hormone cortisol. Now, the hippocampus, which is the brain's primary memory center, contains a very high concentration of these cortisol receptors. When it gets overloaded with stress, the hippocampus essentially just shuts down. So that terrifying moment when you blank out while staring at an exam paper, it isn't a personal failing. No, it's a biological inevitability caused by stress hormones physically blocking memory retrieval.
And this brilliantly illustrates our next overarching principle: brains in pain cannot retain. It's a simple, catchy truth that perfectly captures the neuroscience. Mountains of homework, overly dense information, and anxiety-driven revision sessions fundamentally fail to ingrain new information. Why? Because they place the brain in a state of severe duress. We end up actively fighting the exact neural mechanisms required to consolidate learning into our long-term memory.
So, if cramming is indeed a total cognitive disaster, what actually works? Well, let's contrast our two main contenders here. While cramming gives us a mere illusion of competence, spaced repetition takes a vastly different approach. Instead of studying everything in one massive, exhausting session, you revisit material over increasing intervals. Say 1 day, then 3 days, then a week later. Each time you return to the material right before you're about to forget it, you reactivate specific neural ensembles. This biological process, called long-term potentation, creates incredibly robust neural pathways. It's literally the difference between building a sandcastle right next to the incoming tide versus laying down solid brick and mortar.
Section 1. The solution, the 3-2-1 study method. So the crucial point is, how do we fix this? Now that we know exactly why cramming fails, let's look at a systematic, multisensory alternative.
Let's break down the mechanics of this 3-2-1 method. It forces you to process information from 3 completely different angles. Step 1, you read a concept 3 times to familiarize yourself with both the big picture and the underlying details. Step 2, you look away and speak the concept out loud twice, purely from memory. And step 3, you write the concept down once, again, entirely from memory. This structured process leverages active recall, which cognitive science overwhelmingly considers the absolute gold standard for encoding information into long-term memory.
Let's actually put this into practice right now with a real-world history example. Our concept to master is the causes of World War II. I want you to read this short text aloud with me 3 times over to really familiarize yourself with the information. Ready? The causes of World War II included the Treaty of Versailles, the rise of fascism, and the failure of the League of Nations. Okay, let's do it again. The causes of World War II included the Treaty of Versailles, the rise of fascism, and the failure of the League of Nations. And one last time for good measure. The causes of World War II included the Treaty of Versailles, the rise of fascism, and the failure of the League of Nations. Brilliant. That's the reading done.
Now it's your turn. Speak the answer aloud with me. Seriously, look entirely away from the screen. No cheating now. Speak it aloud twice, from memory. What were the causes? They were the Treaty of Versailles, the rise of fascism, and the failure of the League of Nations. Let's do that once more, out loud. The causes were the Treaty of Versailles, the rise of fascism, and the failure of the League of Nations. By actually speaking it, you're forcing your brain to actively retrieve the data, rather than just passively recognizing it on a page.
Finally, we move to the last critical step of the whole method. Grab a pen and jot down those key causes entirely from memory. Now, this physical output method overcomes the uncomfortable resistance of active recall. You know that tricky, frustrating feeling when you really want to just peek at the answer? Pushing through that resistance is exactly where the cognitive magic happens. By reading, speaking, and then writing, you process the information in 3 distinct, multisensory ways, successfully locking the knowledge into those strong neural pathways we discussed earlier.
Which brings us to our final and perhaps most important thought of this explainer. Will you ditch the 3 a.m. cramming and try the 3-2-1 method tonight? You now possess the evidence-based strategies to completely transform your next revision program. Stop fighting your own cognitive architecture and start working with it. I highly encourage all you pupils and lifelong learners out there to adopt this multi-sensory active recall approach. You are going to be amazed, and not just how much more you retain, but how much less stressful the entire learning process becomes. Thank you so much for joining me today, and the very best of luck putting this into practice.